Good morning, Trig. We are going to start with lesson 66 today, and hopefully you're watching this because it makes graphing and writing equations for sinusoids so simple. So 66.A, as you can see, we're going to skip. 66.B talks about phase shifts. Remember, that's when our graph has been shifted left, right, up, down, and period changes. So we're going to do a little review. In a sinusoid, now we're talking about sinusoids, okay, so sine and cosine graphs, one period should equal 360 degrees. So a full cycle should occur in 360 degrees, or if it's in radians, that's 2 pi, right? Because pi is 180, so 2 times 180 is 360 degrees. Okay, so this is saying a full cycle. Whoops, that is not how you spell cycle. Should occur in 360 degrees. And remember, a full cycle is one hill and one valley. Okay, so it can be measured like that, or in a cosine function, it could be measured from the top of a peak to the next top of a peak. So there are two ways to measure a full cycle. So when we talk about this, when we're writing equations, I put a little note here. You're going to use the graph, you're going to look at the graph, and you're going to determine how many degrees or radians did it take for that graph to complete a full cycle. And so when we calculate it, it would be 360 degrees divided by the full cycle of your graph. Or if it's in radians, you're going to determine it by doing 2 pi divided by the full cycle in radians. 66.B goes over kind of two ways to write the period. And so one is unfactored argument, and one is a factored argument. And so there are two ways to write our equations using the period that we have determined. So unfactored would look like this. I would write y equals sine, and then in parentheses 2 theta minus 90 degrees. Now 2 theta means that there are two full cycles in 360 degrees. That's what that means. When I write that, it means that when I looked at the graph was able to complete 2 full cycles in 360 degrees. The factored version would look like this: y equals sine of 2 parentheses theta minus 45 degrees. Now, this is the way we're going to write our functions. The number here would represent our period, and this would represent our phase shift. So it is the easier way to write the equations is by writing it in factored form. So let's do the most important part. Let's go over the general form of our functions and talk about each piece, and then we will use that with our graphs today. So general form should look like this: y equals a plus b, and then either sine or cosine here, c parentheses theta minus d. So I'm going to identify, you and I are going to determine A, B, C, and D from our graphs. So let's review. A is our center line, which is also representing our vertical shift. Graphs should occur on, the center line should be on the x-axis. So if it's not, then I know that this graph has been moved either up or down. But A should be wherever our center line has occurred. B is our amplitude. So remember, that is the distance from the center line to the peak, or the center line to the lowest point or valley, however you want to think of it. C is our, well, that's a weird way to write an arrow, Michelle. C is our period. Remember, that will be 360 degrees divided by however long it took the graph we're looking at to complete a full cycle. And D is our phase shift. This would be our horizontal shift. The graph has been moved to the left or right. And I will review that as we go. So I have 3 graphs, and we are going to practice writing the equations for both sine and cosine for each one. All right, so here is number 1. Sorry, let me fix my computer screen. So we're going to write both the sine and cosine equations of this sinusoid. Notice it's in degrees, so we are going to use theta. So let's start by determining our letters. So let's start with A. Remember, A is our center line. So if this top is at +7 and this is at -1, these are a total of 8 units apart on the number line, right? 7 positive and then +1. These are 8 units apart. So if I divide 8 units by 2, that's 4. So the middle would be 4 units less than 7, which would put our center line at 3. Right? Because then from here to here and here to here is perfect 4 units. Okay, so that just determined B, our amplitude, is 4 units. So this is center line, amplitude. Now I need to determine our period. So looking at this graph, there are 2 ways to determine a full cycle. I'm going to go, and it doesn't matter how you measure it. For example, I could measure a complete cycle going from the top to the next top. That's one way, and to calculate how many degrees that took. Or review to go from the center line to include a valley and peak. So you can go from center line to center line or peak to peak. It's up to you. It's also maybe whatever's easiest based on how they labeled it. So I notice this center, I'm going to do the center line to center line. So this is at 45 degrees all the way to 540. This looks like every half box. So this would be plus 540 plus another 45. Oh no, sorry. If I want to know how many degrees it took to complete that cycle, it would be 540 plus 45 degrees minus where it started, right? I'm trying to measure from here to here. So I know this is 540 plus 45, so that's 595. Minus 45 would give me a full cycle of 540 degrees. So I then have to take, remember our formula to figuring all of this out is to then determine it's 360 degrees divided by our full cycle. So we determined that it took our graph 540 degrees to complete a full cycle. Had I measured from here to here, that would have been 90 plus 450. Either way, I would have ended up with 540. So I'm now going to, I'm going to put a semicolon because I'm trying to determine a full cycle here. So I have 360 over 540. I'm going to reduce this by 180, and so I get 2/3. So C equals 2/3. Now I'm going to find my phase shift. And there's going to be 2. One for sine and one for cosine. So remember, let's start with cosine. Cosine should be the nearest peak near the origin. So for cosine, I would use this peak here, which is at -90 degrees. So for cosine, my phase shift is 90 degrees. Sine would be the on your center line, nearest the origin on the way up. So there's 2 places I could use for sine, either here or here, but it should be on our way up. So I'm using this for D for cosine, and I'm using this point here for my D for sine. And so that is -180 plus 445, that would be 225 degrees. So let's now write our functions. So y equals a plus b, and let's start with our sine function. I do the period first, and then sine was negative 225, so this would be, these are both negative. So in here, this would be 225 degrees. Let's talk about cosine. Everything should be the same. Center line plus amplitude, cosine, period, theta plus, the only change will be, the only difference, notice in these equations, is d, their phase shift. And so these are the equations. All right, I know that was a lot, and we're just going to do 2 more, and then we're done with this section. So in number 2, I'm going to identify the same pieces, A, B, C, and D. So let's start with our center line, right? That's the easiest. Please note this right here is a negative 4. So 12 and negative 4 is 16 units apart. If I divide that by 2, I get 8 units. So 12 minus 8 puts the center line at positive 4. And our amplitude is right here. This is our amplitude because I'm 8 units apart here, and 4 to negative 4 is 8 units. So let's now determine our full cycle for part C. So let's say I go from here to here. So I'm determining my full cycle. So this is at negative, so 7 pi, because I'm looking for distance. So 7 pi over 4 plus 1 pi over 4. I did a full cycle on 8 pi over 4, which would be, anyone? Sorry, that's out of habit. Nobody's here. That would be, I should simplify this, C equals 2 pi. And our cycle, or period, should be 2 pi. So 2 pi over 2 pi would equal 1. Our cycle, our period is 1. This is 360 degrees. So it's what it should be. So now let's determine D. So for sine and cosine. So for sine, it would be the center line point on our way up. So I would use this. So sine is pi over 4. Cosine would be the nearest peak to the origin. And so that is 3 pi over 4. So let's write our equations. Y equals our period, our center line, so 4, plus B, which is 8. And let's start with sine. Our period is 1. And then because this is in radians, I'm using x. These are positive, so x minus pi over 4. And you do not need the 1 here. Okay, so you could erase the 1. So y equal cosine should be, everything should be the same, but this would be 3 pi over 4. Okay, and those are our equations. Last one. So let's start with our pieces. A is our center line, so 4 to negative 2. So let's find the distance between those. 4 minus a negative 2 is a positive 6. And so if I divide that by 2, I get 3. So 3 units from 4 would mean that this right here is at positive 1. So this is at positive 1. My amplitude is at 3. Let's do our phase shift first because it's easier for both sine and cosine. So for sine, I'm going to use this one here on our way up. It looks like each box is 60, 120, 180, 240. So this would be at negative 60 degrees. Cosine, notice cosine. Cosine is right where it should be, so there has not been a phase shift for cosine. So now let's determine our full cycle. So I'm gonna go ahead and use from peak to peak. I think that's easier because it's perfectly labeled for us. So it went from 0 to 240. So a complete cycle happened in 240 degrees. So C equals 360 divided by 240. Reduce that. I'm going to reduce it by 120, and I get 3 over 2. So let's write our equations. Let's start with sine. So 1 plus 3 sine, our cycle, or period, sorry, 3 over 2. And then this is in theta, so theta plus 60 for sine because it's a minus, and it should be opposite in here. And then cosine is 1 plus 3 cosine, 3 pi, and this would be theta minus 0. So that can be rewritten as y equals 1 plus 3 cosine, 3 over 2 theta, minus 0. I don't need it. So this is cosine, this is sine. And that completes our section. So for our homework, I'll go ahead and write it on my notebook. We're going to, for homework 66, we're going to skip numbers 5 through 7, 17, 18, 20, and 30. Thank you.